Okay, so the section that we are going to go over, and I'm going to put on YouTube, is going to be for Chapter 2, Section 6, which is rates, ratios, and conversions. Let's go over your homework so that you have it to access when you get home. We're going to start with problem number 9 on page 119. Number 9 was a word problem. Okay? Trisha ran 10 kilometers in 2.5 hours. Jason ran 7.5 kilometers in 2 hours. And then Olga ran 9.5 kilometers in 2 25/100ths of an hour. Okay? All right, so it's asking who had the fastest speed. So for that, you're going to use unit rate. You're going to find out who ran the fastest per hour. Okay? Now, the first thing we do when we can do unit rate, what did we say ratios were? What operation are they? Multiplication, division. Division. So when we're talking about unit rate, we are dividing. All right? So 10 divided by 2.5 hours would give us the unit rate for 1 hour. So for Trisha, 10 kilometers in 2.5 hours, if we divide 10 by 2.5, how fast did Trisha run per hour? 4 kilometers per hour. Very good. Okay? Now, the next one is Jason ran 7.5 kilometers in 2 hours. So if he ran 7.5 in 2 hours, what was his rate per hour? 3 75/100ths kilometers per hour. Okay? And then the last one is Olga ran 9.5 kilometers per hour. In 2 25/100ths of an hour. So now you have divided that on your paper. What is Olga's rate per hour? 4 and what? 4 2/10. 4 2/4. So 4 5/10. 4.5. 4.5. Okay. All right. So Olga ran 4.5 kilometers per hour. Trisha ran 4 kilometers per hour. And Jason ran 3 75/100 kilometers per hour. So who had the fastest speed? Olga. Okay? Olga. Jason had the slowest speed. He only ran 3 75 kilometers per hour. And then there was Trisha, who ran 4 kilometers per hour. And then there was Olga, who ran 4.5 kilometers per hour. So she would have been our fastest. Okay? All right, so let's move on to question number 10. That's another word problem. Bellingham, Washington had an area of 25 4/10 miles and a population of 74,547 during 1 year. Bakersfield, California had an area of 113 1/10 miles and a population of 295,536 during the same year. Which city had a greater number of people per square mile? So once again, it's asking for unit rate, which means what do we do with our two numbers for our two different counties? We divide to find the unit rate. How many per square mile? All right? So we have set the first one, which is Bellingham, Washington, had 74,547, and that was for an area of 25 4/10 miles. Okay? So when we divide those numbers out, what do we get? 74,547 divided by 25 4/10. You have to speak up. Okay, 2,934. All right, let's see. Hold on.
What was the problem?
Okay, so when you divide those numbers out, you get 2,934 and 9/10. Okay? Now, let's divide the other town to see who had a greater number per square mile. Now remember, it's asking per square mile. So that is how many? 1. Okay? So that means that they're asking for unit rate, so you divide. So the second one is 295,536 people, which automatically you look at and you say that's larger, so you're thinking they probably had more people. However, they had a larger number of square miles of 113 and 1/10. Okay? So to find their per square mile or their unit rate, you divide the two numbers, 295,536 divided by 113 and 1/10, and you get 2,613 and 5/100. Okay? So the first town had 2,934 people per square mile. The second town, although larger, only had 2,613 per square mile. Now back to the original question, which says, which city had a greater number of people per square mile? So would it be Bellingham, Washington, or would it be Bakersfield, California? Bellingham, Washington. All right? All right, so let's move on to some of the conversion problems. Once again, there are 2 steps to conversions. Okay? The first one is to identify the conversion factor. Identify the conversion factor. Once you identify the conversion factor, you look at your 2 units, okay? Are you converting from days to years? What would your conversion factor be between days and years? 365, okay? Now, what would your conversion factor be between months and years? 12, okay? And what would your conversion factor be between minutes and hours? 60. Okay, so you identify your conversion factor. Now that's one number, 60, 12, 24, whatever it is. The second step is to decide whether to multiply or divide. Okay? So when you're converting from a smaller unit to a larger unit, like days to years, what do? Multiply or divide?
Divide.
You divide, okay? And when you're converting large to small, like years to days, you do what? Multiply. Okay? So, regardless of whatever rules the book teaches you or whatever rules I teach you, always check your answer to make sure it makes sense, okay? If you have some crazy, insane answer, some insanely large number, it probably isn't right, okay? And you probably should have done the other operation, which was to divide. So, let's look at the next couple, 11 through 22. Number 11, 63 yards. And we're changing it to feet. Okay? So yards to feet. That is larger to smaller or smaller to larger? Yards to feet. Larger to smaller. Okay? So does that mean we are going to multiply or we are going to divide?
Larger to smaller. Divide.
We're going larger to smaller. Okay. Let's see if we multiply. 63 yards to something feet. So how many yards, between yards and feet, what is the conversion factor? Your conversion factor is 3. Why? Because there's 3 feet in 1 yard. So your conversion factor is 3. Now we have to decide, what are we going to do with these two numbers? 63 and 3. Are we going to multiply them or are we going to divide them? Okay? So you guys say we're going to multiply because it's a larger unit to a smaller unit, and that's correct. We're going to multiply. So 63 yards times 3 feet a yard would give us the total amount of feet. So 63 times 3 is how many? 189 feet.
No, it's 3 feet.
189 feet, okay? So you've got 63 yards. For each one of those yards, it equals 3 feet. So you're going to multiply. That would grow, okay? All right, number 12. 168 hours into how many days? 168 hours is how many days? All right, so we're going smaller to larger, hours to days, right? So are we going to multiply or are we going to divide? We're going to divide. Very good. So 168 hours. So what is our conversion factor between hours and days? 24. All right, so now we have 24 as our conversion factor. Now we have to decide what are we going to do with these two numbers, 168 and 24. Are we going to multiply them together or are we going to divide them? We already agreed on that. We're going to divide. So 168 divided by 24 would give us how many days? So how many is it? 7 days. Very good.
Oh, yeah, 7.